as we're talking about circular motion and Newton's law related to circular motion, it is important to know the definition of the period and frequency of circular motion. Any object spinning around a center is called an object that is performing circular motion. Circular motion is directly related to the cycles. Cycles and revolutions are directly related to periods, and periods are defined by frequency. So when you have a baseball player that throw a ball at a certain speed of 145 km per hour, and by moving his wrist in a certain way, this ball will be spinning as it is moving towards its target. When it spins, it has two velocities: the velocity that approaches the batter and rotational velocity because of the spin. Now, the rotational velocity can be measured by measuring the time it takes for one complete rotation. One complete rotation is called a cycle or revolution. So if you bring a pin and put a point on the ball and you have a high-speed camera tracking that ball as it is going to the target, you see the ball spinning, and you can trace the point or the dot that you mark on the ball, and you can see it is spinning as long or at the point where the mark that you put on the ball come back to the same position after full rotation. That is called one cycle or one revolution. And the time for one cycle to take place is called a period. The period is measured in seconds per cycle. So how long did the ball take until it spin from this point to this point? Now, defining frequency. Frequency is a measurement indicating number of cycles the object make at a certain amount of time, usually per 1 second. The SI units for frequency are cycles per second, or more known as Hertz. You might have noticed that the units of frequency are cycles per second and the units for period are seconds per cycle, so they are vice versa relative to each other. So you can represent that in terms of a relation. So the period t equals 1 over frequency, and frequency equals 1 over t. As well, we're interested, as we're talking about circular motion, with RPM. RPM is abbreviation, stands for revolutions per minute. We sometimes call it, instead of RPM, we call it rotational frequency. This unit is not really measured by the SI unit. It is commonly used commercially in products like power tools. RPM is revolution per minute and different from Hertz. It represents number of revolution in 1 minute instead of 1 second. RPM is always 60 times bigger than the value of Hertz. So RPMs are kind of other representation for Hertz. Hertz is revolutions per second, while the RPM is revolution per minute. You can do the conversion factor using this equation. Hertz, if you multiply by 60 seconds per minute, would give you RPM. RPM divided over 60 seconds per minute will give you the Hertz. Now let's take an example on how to find the frequency. Hard drive is in your laptop, in your PC at home. It stores data on a thin magnetic platter that spins at high speeds. The platter makes one complete revolution in 0.00833 seconds. Find the frequency in Hertz and in RPM. So we have the t here. The complete revolution is the period, equals 0.00833 seconds. Find the frequency in Hertz and RPM. We know that period equals 1 over frequency, frequency 1 over t, so the frequency would be 1 over 0.00833, that would be 1 in Hertz. Now we know that from the conversion equation that we have, that as long as you have Hertz, you want to go to RPM, you multiply by 60 seconds per minute. That would give you the frequency to be 7.2 by 10 to the power of 3 RPM.